Hey, Christian.
Us.
Hey, I did want some catch you say, Enchibia. Omu here, dear, maybe who and no more. Omu come on beko. Enchibia. Be on my back kutu prick. Obi to say Alphonse. Now, or the actual
Omunya Juma warehouse.
or the actual pine. Omo Juma Moya, no, need your Moya, no tia, only moment here. Or the actual pine. Abdullah, only one kuku and jam crack, no doubt. After by the time I see I hear you, first one started, that was 2020. See ya, and yeah, na after nipa no bebree no drop you off. Na a car minute, a boy way, Pabna, on not to say, or shame a drum for your juma, or yeah, and yeah, twice one and fast for basso. See, hey, yeah, probably I'm an eye by edge boy, or we will be rams. Oh, it will be a match than I did that. We will be a match than I did that. No other father. And yes, any Omra interview, and I'm some man interview questions in as well goes here. And I'm sad the better now. Besides, here the interview as I can make any interview, be more sending. Interview time, so I just want to know you're fan of that. As I can share interview, that's one or more Kahudi, you know, boy, I interview. And 4 years later, boy, the year more, you know. But Terraform exams, then your next, your first exam, your BG, Terraform. Name it exams. The same can be bumpers and catch up by January, the near try exams. January ending, the new Biako try is about $75. Uber register. Now, our control. You better practice.
And physical exams, Anna.
Physical exams, I will continue to say, medical cameras, swap structural. Remember computer ABC questions. Besides set code. Questions multiple choice. Now, what control? We are not so pass here. Mama certificate. Yeah, look out for it. Hello, Anthony.
Hello.
Design.
Walk on, that's way.
I been there, Charlie. Yeah, that's what. Yeah, power on.
That's good. That's good.
Power on.
And be too quite a crowd. Tina me number 2 so.
Yeah. So catch it.
Yeah.
So the Terraform basics no name did that.
Oh yeah.
But when your exam now come back from what?
Unless I'm ready me metro. But they say no omo pese metro Azure ni GCP no.
Me person metro Azure AZ900 no. End of December. Me yes our course no.
Yeah, we almost say metro AZ104.
AZ104. I know
I don't know yeah the next step above 900 no.
900, okay.
Say it's the requirement to say yeah. Now my GCP no. Be a made for Terraform no so account, but be next year.
The Azure no Azure fundamentals no Azure 900.
Yeah, Azure 900 that is the very basic.
AI fundamentals 900, AZ 900, and Azure data fundamentals 900.
Okay, I know they mean
no. No, we are ultimately so yeah associate no Azure administration, Azure developer, and no Azure security engineer. And data scientist, Power BI data analyst. Oh wow, data engineer on Microsoft Azure, and an Azure data admin. Now to be an expert, where Azure solutions architect and an Azure DevOps engineer.
Yeah. Okay.
So
check it Azure AZ104 now. No, yeah.
Admin, Azure admin, AZ104.
Yeah, Azure admin. I don't know,
It is a AWS systems admin.
Systems admin, yeah.
Sysadmin.
Yeah.
Okay. Yeah, in fact, next year the person is start certificate go with this.
Yeah. I get me throw man, I got throw video, man.
Yeah. That name 900 no means 900 no. It's all about fundamentals of what is a cloud computer and so forth.
But I think it will be for level I will know any knowledge I will need more AWS, Opa, yeah, 104, no. Because 900 is too basic for you.
And somebody started.
Say, the concept, the concept is not too far off AWS.
But the market me say, Azure, I haven't practically been working there that much. It will be best for me to understand and maybe so the naming conventions maybe I don't want to pressure myself too much.
Trust me, okay, so yeah, 104 now bet me. I said my 104 no my kakra. It's very similar to AWS. The naming conventions, yes, you are right. The naming conventions might be different, but it's still the concept is still the same. The way it works, everything is still the same. Yeah, yeah, because Azure, for instance, any infrastructure you create, you have to create a resource group. You have to create a subscription.
Yeah, I've done that.
But I don't say AWS no enter.
There be AWS, you just create an AWS account and everything.
You create the account, yeah.
It's Azure. An account in Azure is more or less a subscription.
A subscription, yes.
Yeah. AWS, an account is a subscription. Yeah.
Yeah.
Anyway, so we will be doing certifications as we've been discussing some of the certificates that cloud engineer you need. And DevOps engineer, some of the certificates you need. And the first one as a team we will be sitting will be the Terraform, because that's since we started, this is the first tool that we are using, and we are going to sit an exam of. I think I feel so we have to sit an exam. So what I'm going to do is, since there's a lot of people here who haven't been here since we started the Terraform, I'm going to give Chris about 10 to 20 minutes to explain. You're saying 8 to explain what we've done so far. I will help you in the sense that I'll help you tell you what we've done, and then you explain them. Okay. Next time when we teach you, take notes. You take notes. Right. So as we know, everybody needs to know these two things. Okay. Everybody. What is infrastructure? Yeah. Infrastructure. And then from there, then you know what infrastructure, because these will come in the questions. Infrastructure as code. Okay, so that's the basics. Terraform is the tool, one of the tools that is used to manage your infrastructure as code. Okay, that's why I want people to really understand what the word infrastructure is. Can someone here help me with what they think an infrastructure is? It can be anything. Anything. The word infrastructure doesn't have to be with IT. Infrastructure. Anybody? And Anthony.
Layman's terms, I would say infrastructure is like components of a building.
Okay. Yeah. The building, everything that came together.
Yeah.
The building. Yeah. Components.
The components.
Yeah. Anybody can use? Someone use the building. John Luke.
Yes, sir.
What's in infrastructure? In any environment, someone use the building. That's construction.
Well, I take it as each and every material you put in something you build.
You know, you can actually ask your boss as well.
I know.
Infrastructure in English dictionary, the basic physical and organizational structure and facilities, example, building, roads, power supply, needed for the operation of a society or enterprise. Now, listen to the English again. The basic physical and organizational structures and facilities. So the basics, physical and organizational structures and facilities, example, building, roads, power supply, needed for the operation of a society or enterprise. That's an infrastructure, according to Google. So here too, there's another way. Infra means below. So the infrastructure is the underlying structure of a country and its economy. The fixture installation that needs in order to function. Now, I want us to forget about the first part and focus on in order, needed in order to function. And the other one was needed for the operation of the society or enterprise. And that's the infrastructure. So you think that is a basic underlying of something that is needed for something to function. If you check something out, these things out of it. So it is basic things that come together, that when those things come together, those things are needed for the function of something. Something needs to go on, and that is what is needed for that thing to go on. So let's bring it into IT. Okay. IT infrastructure or information technology infrastructure is the foundation that supports a company's technology, resources, and applications. You see how there's something, which is the basic, the foundation, that is needed for something, the company's resources and applications to function. Does it make sense? Guys, we are all learning. We are all discussing. Yeah?
Yeah.
So you get what the infrastructure. So here, Windows server on an so for you to your company to be able to, if a company is a design company and they design brochures and do things like that, all they need is some softwares, PowerPoint here, So who are the designers? Photoshop here, Acrobat there, and so on and so forth. So for this company who produces or provides designs to run, the employees will need these tools. These tools are part of the infrastructure. These tools will run on an open operating system. That is also part of the infrastructure. So which operating system that you choose will be part of the infrastructure. And then they will need a computer to put the operating system on. The operating system will be needing, because of the software that you're going to put on the machine, you can then think about the infrastructure of the computer. Computer is part of the infrastructure, and you will configure the computer or set specifications and say, for a designer computer, I need a touch screen. I need the screen to be this big. I need the memory to be this big, this small. I need the SSD. I need this. These are all part of the infrastructure. So before the person actually comes and start doing their work, which is designing brochures for people, you are the one who is going to make sure that the laptop that the person is going to use is set up, ready, secured, everything for the person to use to start doing their work. All they need to do is to click, turn on, log in, and then launch the applications, and it's working, and they will continue from there. So you see what an infrastructure is. But now we're saying, okay, this infrastructure, Windows, we know how to configure Windows. We have to create a user for this person. This person has to have access to this, all of that. We are coding it. We are writing a code for it. And in that code, if we need to do another computer, it's easy. We have a code for it. Tomorrow someone comes, it's not that, oh, someone is going to go and do this one by one. No. Maybe, of course, if it's physical laptop, you will have to go and buy the laptop, but still you have the specifications that you need coded somewhere. The email that you're going to write to the vendor is sitting there. Everything is there. So when a new person comes, you spin up another email, you attach the specifications to the email, and the process starts. Even that, parts of it, you have actually coded. I'm just using these so that you understand what is going on, okay? But in cloud, everything can be coded, because you can see there's no physical computer. So if you want to go and buy one of these computers in the cloud, you can code all of it. Code all of it, everything. I want a Windows server. When the Windows server is spun up, I want to connect to it. I want to then make these changes. I want to change the parameter here. I want to make sure that I've updated Windows. I've done this, install that, install. All of that can be coded. Everything can be coded. That's what infrastructure as code is. And you saw that we were able to create networking resources in AWS. And then you remember also that I told you that every resource, every tool, every device in this world, every device in this world sits in a network. Your mobile phone sits in a network. Your laptop in your house is sitting in a network. Without a network, none of these devices will work. That's the basic infrastructure, one of the basic infrastructures. So we went to AWS and we were creating such resources manually. You saw how to do it. You create the VPC, you create the subnet, you attach the subnet, you create the route table. You know about route tables, what they do. You know the internet gateway, what they do. You were doing that, but you're doing it manually. Now we are saying, let's code this infrastructure. And the tool to use to code this specific networking resource or infrastructure is Terraform. Any questions? Nice. Okay. So that's Terraform. So from infrastructure as a code, infrastructure, and what is it as a code, we started into Terraform. First thing you need to do is to learn how to install it. Okay. If you can't install it, you can't use it. Terraform, I think, may only work on Linux. I need to confirm that, but we have been using Linux to work in Terraform. Yeah. So I'm going to let and we have a Cloud9. Everybody here has a Cloud9 environment. You can follow the steps. There are videos there that I've shared, and then you can install Terraform and play around with it. We then did the Terraform installation. We have a video, and then we started working on the workflow. So, Chris, tell me, what is a Terraform workflow? Tell people. Mr. A, we are waiting. You're on mute.
Oh, sorry. So I would say the workflow is basically the steps in order to the steps through initialization to that which ways I want to use the right ways. Okay. So Terraform workflow is basically the steps through which one takes to manage his or her infrastructures on the cloud, basically. So
all right. So the workflow is you write the code. Yeah.
Yeah.
You validate the code. You plan the code, the resource creation, everything. You review it, obviously. You then apply. You can destroy and initialize. You have to initialize first. So remember the workflow we had in Git, more or less this. 1 minute, give me 2 seconds. So just as we did Git, and we had Git init, Git staging, we move things to staging, Git add. That's the workflow. Terraform has its own. Okay, so we did get Terraform workflow. We went through the init. We went through the basic concept of Terraform: plan, apply, destroy. And then we looked at resource addressing, how we write a block, a Terraform block. We've currently looked at the provider block. We looked at the resource block. Yesterday we looked at the variable block. And then we also looked at the output block. Okay. The videos are there. Yesterday we looked at states, Terraform state files, what they do, why they needed, what it is. So we looked at the state command, where we did the state list, state show, state so on and so forth. Okay. So we're going to build on that variable, the output that we did yesterday. Okay. I'm going to build on that. So any questions?
Nope.
Cool. All right. Let me share my screen then. And then let me log in. But let me log in first. Today I'm using only one laptop, so you'll see these things too. Don't worry. Me too, I'm a person. All right, guys, those who are going to follow up with the task, you can also log in. Oh, this is not the password, is it? This is not nice. Sometimes I come here, Cloud9 will work. Sometimes I come here, Cloud9 will not work. Which one did I use? Every day. I have to go through this nonsense. Every day. You find an AWS account that I can Cloud9. Oh, this one, Bernard upon. Okay. I need to name that and put Cloud9 to it. Okay. So I'm in already there. So basically, whatever you do, you need your workstation. It can be your laptop, but I choose Cloud9 because whenever I come, everything that I'm doing is there. Okay. So yesterday we used the output to display the actual output after the resource was created. So we had an output file and we outputted the CIDR block. No, this is not the output file. We got the CIDR block and the ARN. We got all the tags as well. Okay, that's the output. So in this folder, we have the main.tf where we set the backend. Yesterday we did the backend as well. The backend block, we got the provider block, and we have the what's it called block, the VPC creation itself. We got a block there, and we then added variables. where you can see that here we are referencing a variable, and here too we are referencing a variable. And in the variables file, we set the default value for this variable. And that yesterday I did tell you that you see why we have variables, okay? And today we're going to touch on those. Now, the first thing we're going to do is we're going to add a VPC to the this subnet. This subnet to this VPC. We're going to create the first subnet, okay? And if we go to AWS, we go to VPCs, you see that we have some VPCs that we already created. I'm just going to go and learn and study the subnets, how we created them. So you can see that we got tons of, well, we got some subnets here. The subnet always have the VPCs attached to. So these subnets are all for the default VPC. The current VPCs that we have here don't have subnets for some reason. It's only this VPC that has a subnet. Okay, so we're going to create a subnet for this one, which I think, no, we haven't actually created. We destroyed it yesterday, so we're going to create a subnet. Now in Terraform, anything you want to do, you have to go to the Terraform website, unless you obviously know, yeah, already. So we're going to create a subnet. We all know what a subnet is. As time goes on, we'll be adding more resources to our VPC to the extent that we will start learning networking as well. Okay, look, it's a typical example of a subnet is that. Okay, but they have the whole resource documentation here. So when you create a subnet will belong to a VPC. So you start the resource block, and then you say the subnet, and obviously you remember the name. We're going to name it. Okay, so let's take this and take it and put it in our code. Okay, so this is the VPC. We will then come here and say we are going to create a subnet for this VPC. Okay, we can use variables, which we are going to. Okay, and we can also add a name here. Now, this is what is the most important one. Here, we need the VPC ID, because every subnet requires a VPC to sit in. You can't create a subnet on its own on AWS. Like you create a VPC. If you create a subnet, it needs somewhere to sit. It is a subnet for a region, subnet. So you cannot create a subnet without knowing where it has to go and sit. And this is one of the things where I'm going to also teach you something called depends on. Okay, so let's tag here, depends on. Terraform has this feature where you're creating resources and you're saying that one of the resource depends on another resource. So what Terraform does is it will make sure it finish creating this resource before it goes and create that one. Okay, give me 1 minute again. Today master is costing a bit. So we'll work on the depends on as well. But I want you to focus on here. Oh, master, come on. Hi. What's he doing today? Right. This here. Can someone tell me where we get this from?
Where we get what? The AWS VPC.main.id.
Excuse me. What did you say? Chris?
Is it the AWS VPC.main.id?
Yes, line 27, equal to aws.main.vpc.
So the AWS VPC.main is the VPC, and then we are getting the ID for the VPC.
Well, that's what is written there. So don't, it's like saying a straight line is a line which is straight. You're just reading what is there to me.
Benny, I think it is referencing to a resource called AWS VPC with its name to be main. Then you're referring to an ID of that VPC.
Yes. Well, the output. The output. So this is the VPC, and in the output we have information of the ID. Okay, this is what we've put. This is the value we are putting there. So in a nutshell, we can actually also put the output there. Okay, this is exactly the same. We created this output and say, okay, give us this output. So whenever you create a resource block, I told you that resource comes with, at the bottom, attribute reference. Each resource. This is the input, what you put in to create the resource, the variables you put in, the parameters. And this is the output that comes out. This is it. Okay, so in each of the documentation that Terraform has done, when they tell you, they will tell you what argument reference and the attribute reference. These are the ones that you can get out. So when we create this VPC, we can get the ID, can get the ARN, can get all of these, we can get it out. We can reference it. We can reference this. And to reference it, what we do is you go to the main here. This is the resource block. And in Terraform, the resource is AWS VPC dot this name here. Then we then put dot ID dot ARN dot whatever. Okay. So if we want the ID, we're saying that we want the ID of this AWS VPC, which is called Bernard Test 1. And we want the ID reference of it. So what we can do is we can actually do the same here. We just have to copy this. So if you have 3 VPCs created, then it will know which of the VPCs you want the ID of. This is it. Okay. So remember that we are calling this, and we want this name. So if there's 2 VPCs, there will be the next one will be 2, isn't it? And we want the ID reference of this, and we want to use that as a value to create this. If you don't have, if the VPC was already created, what I could do is I'll go here and then I just copy the VPC ID because it's already created. There's other ways to get this, but I'm just telling so that you understand. I just copy this VPC ID and then I will just put it there. I just want the ID. Anyhow, I get this information here. This VPC will be created, subnet will be created. But what's the point in going to collect information from AWS? What if the resource is already not created anyway? And that's why we have to be smart here. If the resource is not created, create it. When you create it, get the ID and use it to create a VPC. You get the point now? Hello.
Yeah.
Okay. Oh, how many people are there today? 5 of us. Good. Okay, so that's what we're doing. So remember, we're using the output to use the information in this here to create another resource. That means we can reference a lot of things in the VPC if needed. Okay, here we can actually put the VPC name there. We all know the name. We can just copy this. Okay, copy this and put it here. That is the name of the VPC. So the name of the subnet will also be called, we want to call it the same name as the VPC. Give me 1 minute. Right. Now we are playing a lot more here. Yeah, we want to play more because we probably would want the VPC name dash something. We don't want to just put the VPC name. Maybe this will be a private subnet or a public subnet. God damn it. So we probably would do, okay, we want the VPC name, but we want to continue with it. Okay, and there's a way to do that. Okay. So let's say okay, so it's called string concatenation. Who knows who has heard concatenating before? So here the resource name is var dot that, and then we want to concatenate something else to it. Yeah, so what we're going to do is as they've done here, they have put everything in inverted commas, and now they are concatenate. You can also do joins, guys. It's going to get messy soon. Okay, but don't worry. These are all syntax, programming language syntax, or things that you just need to know. Okay, so what we're going to do is we're going to do some concatenating. Okay, we want to say that this is a VPC. So first things first, let's just copy this and put it in our code and see what will happen. So we're just going to reference this. So here, what we'll do is we will then put this first in inverted commas, and then put this in curly dollar curly brackets, and then close the curly bracket. Yeah. Then everything we add here will be added to the name. So public VPC -1. You get it? So what we are trying to say is the tag of this name should be the name of the VPC. Then we want to add something to it, which is called concatenating. Yeah. And what we want to add to it is we want to say that it's a public subnet, no VPC. 1. We want to call it the name of the VPC public subnet 1. Okay, so we take the VPC name, Okay, and then here we could actually use the tag. We can actually reference the output of the tag here. So whenever, if anybody changes the name of the tag, it will also be changed here, but this one works too. Okay. You get what we've done now. Yeah. So anything that gets put in this variable will be put in front of it. So if you create the VPC, the name of the VPC will be appended to is it surfaced to the public subnet, and it will be the first public subnet that we are creating. Okay. Now we need to do the CIDR block, and here we're going to go and put it in a variable. Okay. So the name of the variable will be, obviously we add it to the variable dot. We call it public subnet 1. Okay. Public subnet 1 dash CIBR. Yeah. So we will have to go and create a variable called this in the vars. Copy. We go to variables file, and then we create a variable. We copy. We just then you paste this there. Okay, so we created a variable, and we are saying it's a string, and we're going to pass the default value here. Okay. All right. So what will be the first subnet? So what I'll do is, as I said, I'm not doing subnetting. I should let's see what the VPC CIDR is. 10.2.0.0.16. Good. So I'm just going to say I need 6 subnets in a VPC with a CIDR block. This what will be the CIDR of all the 6 subnets? There we go. Subnet 1 is that, subnet 2 is that, subnet 3 is that 6, and so just take this one. All right. Gone are the days when we wanted this information. Take us a lot of time. So this subnet will be that. Okay. This subnet will be that, according to ChatGPT. But AWS can cry about it. Let's see if AWS will cry about it. I shouldn't cry. All right. So this is it. I know this might be a lot, but I also know that if you put your mind to it, you will. Remember, we are not doing subnetting, so don't ask me a question about subnetting. What we've done here is we are creating this, and we are passing in the values. And I told you the other day that when you finish learning about the keys, so this is a key pair, key value pair. This is the key, that's the value. They come as a pair, key value pair. Remember when we did files, YAML files and stuff, we learned about YAML files and stuff. So this is a key value pair, okay? Key value pair. The keys are easy. It's needed. VPC ID is equal to, but the values, there's so many things we can do to the value to get the value. And one of them is getting the value from another here. The other one is concatenating, as you can see. The other one is putting it in a variable, as you can see. And there's going to be a lot more manipulation when it comes to values. How are we going to deal with these values? Sometimes you can loop through, you can do loops, you can do logic here. If this, then do this. It's a lot. Trust me. Okay. But everything we're going to learn is going to be how we manipulate these values to make the code very, very, very dynamic. Dynamic, so that this here cannot be, if this code is big and we have 10 VPCs that we are creating, you're managing 10 VPCs, and they want you to go and change one name. You have to go through the whole code to go and find the name, or you can have each VPC can have its own variables file, VPC1, variable file 1, then it's easy for you to manage such a code, isn't it? Remember, everything I'm saying now will not make sense later, because there are so many ways to actually do this. But for your understanding and so that I don't confuse you, I want to build on it, and that's why I'm using those words. But when you become an expert and you watch this video back, you know that Bernard said he was going to create multiple variable files for each VPC. No, you don't do that. But it will work. All I'm saying is we don't want to statically put things here to make our life very, very hard if we are managing a big estate. If I show you some of the code, look, I'll show you some of the code. VPC. If you have to create a whole VPC, and AWS itself is creating modules for people to use. So this one, Terraform module to create AWS VPC, someone in Ukraine is doing it. Okay, and he's managing this. And Massa, if you look at this code and what this code can do, and the things this guy you will be amazed. And that's why there is a lot of jobs out there just for someone who knows this program. Okay, yes, for this. Okay, so my point is that's what's going to happen. So now we're finished. Okay, we created a VPC. This here we need to change this because we have to call it. So what I do is I make it all uniform. So this one will also be called this, and I'll just add subnet, public subnet 1. Okay. So the logical name that Terraform knows will be AWS subnet dot Bernard test subnet, Bernard test 1, public subnet 1. So if I want to reference this, I just do AWS subnet dot Bernard test 1, public subnet 1, and I will get the output. So let's put the output of the VPC in the output file. Okay, so if you go to the VPC again, it tells us that we can get the ID, ARN, can get the owner. So the ID and ARN is enough. So we will add that to the output file. So it's good. The format is the same. I'll copy, paste. Yeah. And then all I need to do is to change here. Okay. And normally what I do is I call it the same as what is here anyway, so that I don't get, it doesn't mess me up. So I can call it output this. Yeah. And then I say dash CIDR, CIDR. So that will be the CIDR. And this one will be copy. I'll call this one the same, but I'll remove and call this one dash ARN or ID. No, okay. ARN, and this one will be ID. So these are names that I'm calling them for my own reading the code. When I come to the output, I know that, oh, this one is the VPC ID, this one is the VPC ARN, this one is the ARN. This one is the tags, VPC tags. This one is the subnet, public subnet 1 ID. This one is the public subnet 1 ARN. You see, for my own purpose, for the next person's purpose, I'm making it readable on the onset. Okay. But remember, I need to change this. So it will be where's the code? I need the main.tf. So it will be this. Okay, copy. Go to output. So all you do is remove the curly brackets and put dot in front of it and remove this curly bracket. That's it. Subnet dot that. And then we put the last one will be the dot ID. We want the ID. We copy the same thing. And then this one, we will call it ARN. Yeah. So when this resource is created, to give me this 5 outputs, 1, 2, 3, 4, 5, the VPC ID, the VPC ARN, the subnet tag, VPC tags, subnet ARN, subnet ID, and so on and so forth. So this code is ready for me to go and deploy into AWS. Okay. I save the output file. I save the main.tf. I save the provider. This is not needed, is it? No, this is not needed. This is not part of the code. That's all. So these are the three files that I changed in this. And then I have to initialize because I've introduced another subnet, and the Terraform init will go and pull the plugins needed to create a subnet. Okay, so I go into cd vpc -vars ls, yeah, and then I do Terraform init. This is the workflow. You created write the code, you initialize. So it says plugins, initializing provider plugins, and you have successfully done all of it. It's pulled everything that is needed in it. Okay. And then we plan. The plan would then tell us how the things will look like. If there are any errors in the syntax, you put something there that Terraform doesn't want, it will cry. It could have cried actually at the beginning of the init, and as you can see, it's saying that it's going to create 2 resources. It's not going to change any. It's not going to destroy any because this VPC doesn't exist in AWS. It's going to create it. Okay. And as you can see, it said that it's going to create a subnet will be created and a VPC will be created. And it's going to create the subnet with this CIDR block and it create the VPC with that CIDR block. Okay. It will tag the VPC this, but it will tag the CIDR this. You see, they have changed it's changed the name and concatenated it with what we wanted. See, what we want is the name of the VPC, which is that dash public subnet 1. It has already done that. During the compiling, it has already done that. Here, we didn't put the name there. We just say go and take the variable, and it's done that. Okay. Okay. So now the next is you review it and you apply. Yeah. And then you apply. The apply will do another plan, and it will then ask you, do you want to continue? You can auto approve, but you say yes or no, it will stop or you continue. And it's going to go to AWS Okay, sometimes the code will have values there that AWS doesn't like. So it's at the time when you're creating the resource that AWS will tell you, I can't create this VPC with this CIDR block. But Terraform might not know if you put a wrong CIDR block there. And when we finished, as you can see, the outputs are there. The outputs that we specified in the output file are all there. We said we wanted the ARN of the subnet is there. We said we wanted the ID of the subnet is there. We said we wanted the ARN of the VPC is there. We wanted the ARN of the, remember, all of this that I'm seeing here is because I named it properly down here. If I put this 1, 2, 3, I just remove this and put 1, 2, output 1, output 3, output 3, 4. All I'll see here is output 1, output 2, output 3. You will not actually identify things properly. Okay, and that's why it's good when you're naming things in Terraform, you make it that you can read, readable.
OP, can you please increase the font size?
Oh, crowds, we need.
That be video na quality na so tintia na
Video overhead. Siana, dinner, we see, and who would them what?
that be na I have for me so.
How about now, Mr. My eye doesn't work. How about now?
It's okay now.
Okay. So guys, this is it. We have then added a subnet, one subnet, and we have outputted the subnet. We added tags. So let's go and verify in AWS. Okay. This is a bit too big, master. Okay, so let's go to subnets and refresh these subnets, and voila, there's a subnet just added, and the tag for the subnet is Bernard test 1 terraformed. We're not doing spellings here, so I'm not looking at that. Public subnet 1. See? Subnet, which is attached to which VPC? That VPC, which is also called Bernard test 1 terraformed. Okay, I could have added VPC to it, but terraformed. Right? And it's here. So what I'm going to do, those who can, I want you to create a route table. No, let's create an internet gateway and attach that internet gateway to the VPC. Okay. Now, I'm going to give you a head start. All you have to do is to go to Terraform itself, look for the internet gateway. Gateway. Can search for gateway. Okay. There we are. Internet gateway. Okay. So here, again, you're creating a simple internet gateway. Remember, internet gateways can be created on their own, but it will be good to attach it to the VPC when you create it. That's it. So you need to specify which VPC you want to create the internet gateway for, and you need to tag it. Okay. You need to tag it. That's all. This internet gateway, someone here, you see how they are using the depends on. Okay. They are creating an instance, AWS instance, and they are saying it depends on this. So this is the depends on that I was talking about, but we are not doing depends on now. So who is going to share their screen, or who is actually doing this and is going to attempt the internet gateway block? Do you want me to copy this code and put it somewhere so you can build on it, or you can do your VPC subnet as well? Those who were able to create it yesterday, can you create your subnet, or do you want me to copy this code and put it there?
Yeah, we need the code.
Nonsensical. Right. Let's copy this code. Of course, don't create any resource in your AWS called Bernard test. But so far, do you think it's something that we can do easily, or we understand? Or am I going too fast?
It's yes from my end.
I'm going too fast.
No, it's fine.
Because you've been doing Terraform for like a year now. Why would it not be easy for you?
Yeah, before I have done it, that's what I was about to add.
So you are doing remedials. Oh, why? What's going on here? Okay, the code is in the WhatsApp. It's in WhatsApp. So who is doing it? Raise your hand if you're actually doing it. Anthony, are you giving a crack? Or this obviously we haven't got to the part where it's at your level yet. The basics is still basics for you.
Yeah, I would have done it, but actually I'm multitasking with the family. They are distracting me a bit.
Eddie, you're not trying to tell you because obviously you haven't done anything of that sort yet. You probably watched the video.
Yeah, I watched the video at some point tonight and come back to it.
Cool. Let's see how far Chris and if they can create an internet gateway and attach it to the VPC. So while they do it, we did explain a lot with coming back. Why do we need Terraform and infrastructure as a code? Because the Terraform exam will ask questions around what is infrastructure and infrastructure as a code. It will ask the question. So it's best that you know about those. Why not? Which one of you is going to share their screen? Paul. See, I asked the question and I volunteered him to share his screen. Why do you ask if you're going to tell me to share my screen?
No, yeah, you can always ask. I'm sharing now.
Okay. Chris, be ready. I'll do the same to you one day.
I'm just using your code, just editing them.
We can't see your screen. Can people see his screen?
Can someone see my screen?
I can't see it.
Okay, let me stop sharing and share once more. I hope you can see it.
Yeah.
Okay.
So what you could have done was find and replace.
Oh yeah.
Oh yeah. My
And
gosh.
then this here. I've never used that one here.
You can even use it in Vim. Let's find and replace everywhere.
Yeah. I've done variables. They are where they are here, and I've done the main, which is here. I think I'm going to do the last one, which is.
Do you have the AWS? Did you create the AWS S3 bucket for the backend?
Yeah, I've done that.
Okay.
So this is here. Copy your output file. Now what I do is for cool. So the values I need to check. This is VPC to make sure that is it. So this is VPC.
You first have to make sure you can create a VPC with this code, and then then start working on the attachment.
Yeah. Want to make sure the AWS VPC AWS. RAM. Oh. VPC up here. Subnet. This is small, subnet is small. Yeah. Am I on output? On subnet. And here as well. Control save view. Save here. And save here.
MOP, the assignment is to create a gateway, yeah?
Yes. Create a gateway, attach the gateway to the VPC.
I'll put my output file has a problem here. Then VPC ID should be a small p VPC. Variable. Terraform gateway.
You can deploy your VPC in the subnet and then add the gateway after.
Yeah.
Or you can add it to the code from the onset. But you need to make sure that the code works. It's able to put the VPC.
So I think it worked. Just created it in Ireland. And this is it. When I check subnets, I think this is it. Yeah, it worked.
Okay. But let's make sure we are working in North Virginia most of the times, yeah?
Yeah, sure. I did it intentional. That's why I created. I used yesterday.
But it doesn't matter today. It's okay.
Yeah. So I'm going to create an internet gateway. I'm gonna use this one. We need yeah. Here we go, straight here. And we need
line 30. The information is already there in line 30.
renter, yeah.
That's it. You see, that's all you need is a VPC ID and the information to get the VPC ID is there. You need a name tag, the information is there. How easy is that? You just copy the tag at the top and change the the concatenation is there. Look, line 34. It's a name tag. You copy the whole value, put it there, and change the last part. Just have to be smart, guys.
Yeah, I think that's what is missing.
Smartness.
Yeah. And I call this
So how did you call the subnet? You called it Paul's test 1 public subnet 1. Why don't you call it Paul test 1 internet gateway or IG? Paul test 1. Why are you putting underscore when the first one is dash? Wait, uniformity. If you're underscoring, underscore dash IG internet gateway. Yes, IG.
Okay. So I think I have to replace this one.
You can just call it internet gateway because there's only going to be one internet gateway.
Yeah, I think we have all set. How we save this, go back here, check the plan. No change, I did it save. Yeah, it's going to add the gateway.
It's one dash.
Let me approve it.
Yeah, but you're planning, you're not applying.
Oh.
Hello, footballer.
Plan to add, then destroy, did not use, trying to save this plan. Terraform cannot.
You did it?
No, it's saying something like, what do you think it is?
You don't. You planned. Apply. Terraform apply.
This form.
You still have plan. You still have plan, and you're saying it's not doing. And it's telling you to do Terraform apply now. It's actually telling you there that hey, Apply now.
What's wrong with me?
You were typing plan for apply.
It's done now. I think I have to jump.
Did you add the ARN for the
On the output, no.
in the output? You didn't add anything in the output for the internet gateway.
No.
Yeah.
Output. Value.
It was really good at drawing.
Hmm?
It was really good at drawing.
With Gabriel's what?
Gabe was really good at drawing.
Drawing, yeah.
Did you draw this?
Yeah.
You always draw the same thing. Very good.
For drawing, I think it runs in the Gabriel family. The drawing thing runs in the Gazy family.
I didn't think Gabe would be drawn. I thought it was just baby and sisters.
I haven't seen their parents drawing for their life, so
I can draw.
I don't think it runs in the family. I don't think uncle can draw even if they are going to kill him. Can't draw a carrot. Oh, he's listening.
Very enterprise. This output.
Chris,
Dot.
OP.
sir, you're a bit too quiet. What's going on?
Oh, I'm done.
Hey,
Quick.
I'm saying, hey, share your screen then. So you're getting the hang of it.
Yeah, but I would have to revisit it. That's why I want you to make this the fonts big.
Yeah. The thing is, you always have to revisit. Okay. Now it's 8:30, and I'm going to push you down deep a little bit more, make it even more confusing a little bit. Now you've got a lot of things that you've seen today. You've done concatenating, manipulating the values that these key pairs can add something to it, remove something, and so on and so forth, creating tags here and there. We are going to work on reusing the code. Okay, reusing the code. Okay, we're going to work on reusing the code. So therefore, let's continue, guys. Okay, so currently you have a code and you're using it and you're enjoying and you're having fun. Everything is working, isn't it?
Yeah.
But no, we don't want that. Why should we want everything to be working perfectly fine? So what we're going to do is to make it harder for ourselves. Okay. Who here can explain to me what a module is? The word module.
So I think they are pieces of reusable codes.
Well, you use it in the context of IT. I just want the word module. Okay.
I think like module is like a package of something that is complete. Like among a big thing, you have something that work on itself, like a chapter.
Like a what?
A chapter in a book.
A chapter in a book. Okay.
Yeah.
Okay, who here? Anthony. Module. I don't want it in the context of IT. Module. Anthony. Anthony, I know you're there. You're on mute. We have lost Anthony. Jean-Luc, what's a module?
Well, in general concepts, I took a module as one part of assembled small package to make a full complete thing. Let's say like I have to have more than one module to have any specific application or a specific book, as Paul said, or a specific I don't know, understand it in that way. I don't know if you get it.
Okay.
And you also say it's more like a template.
Well, you're coming into my yes.
Very sorry, I missed your question.
We're trying to understand what a module is. In a layman's term, what a module is.
So module, I would say, is it's a way in Terraform. It's a way
No,
that
not in the sense of Terraform, in a normal world.
I would say making something more repetitive. I mean, trying to create something in a way.
You're having my problems because you know too much. You know about the thing, you've used it before. Now you need to bring it in a layman's term, like, oh, come on, how do I do okay. A module, I think it's a complete tool, one set that can perform one action. So we can say that we are modularizing. We a cup. I'm having a cup in my hand now, yeah. And you know, a cup comes into, I think it's a mug, a teacup, come in two forms: the handle and the cup itself. Okay. What a module is. A module will be complete. It can sit on its own, but it can be reused more often, and you can let me just forget about it. It's a template. It's a template, like that stupid guy at the top there said. So, but a module can be a complete set. So we can have, let's say, it depending on the context. If we are building a city, okay, in a city, what does a city need? a city will need at least a church with a spire. Okay. There could be that church with a spire module already created, a template of it already created. And then if you want to build a city, you need a church with a spire, isn't it? You just bring that a copy of that, or you reference that and use it to build this church in this city, this new city we are creating. A city might need roads. There's a module we've already developed. But remember, that road is also on its own a functioning item. It's a road that we have already built. So within the road, we can also have modules. If I want to build a road, there will be the lane, the middle lane, or if you are building a dual carriage road, there's something in the middle, isn't it? And two roads in the side. So that can itself in the middle can be a module that we can actually reference or take a copy of somewhere and then put it there. Okay, we can modularize all of that. In a house, we can modularize it as well. We can have the washroom, which is a complete functioning washroom that we can actually use copies of and build multiple bathrooms. Okay. I'm not sure if I'm explaining it very well, but does it make sense? In IT, there's lots of modules, packages. People have already done these and left it for people to reuse. Okay. And everybody's building on top of these. Okay. So they are called different things in different programming languages. Okay. But they're all performing the same thing in the end. In Terraform, there are modules as well. You see how we have a VPC code, a code that is creating a VPC, a code that is creating a VPC, and then it's also creating what? A subnet in there. It creates one VPC, creates a subnet, and it creates an internet gateway. It hasn't attached, it hasn't created the route tables. It hasn't done a lot of things in this code. What we can do is we can modularize this code. And anytime we want to create a VPC, we use that code. We will not go and write the code again. We just reference it. We want to create a VPC, create it this way, and then use all the functions of this new code that we have done to create this VPC. Okay, so in a sense, it's like a module makes it easy for you to recreate infrastructure, functions, tools, anything easily, because you're not going down to the drawing board to go and start afresh. So I want to create a church with Aspire. We have a module of that. Use that as a copy, a reference point to quickly create it. So we're not going to hire an engineer to come and do all that again. We've already done it once. It works. This is it. Let's do a copy of that. Okay. So does it make sense? Now the question is, how do we do this in Terraform? This is where I share my screen. This will be the end of today. What is going on here? Right. Let me share my screen. Entire screen. Yeah. And then it's gonna do that, and I'll go here. Okay. So, can you see my screen well? Right. We have this folder here called VPC.
No, the screen is too small.
Your eye. It's your eye. every time this same screen I increased last time, you said it was nice. I come back again, you say it's small. You're moving backwards in every time from your laptop. That's what's going on.
No.
You're lying down on your bed and chilling. Anyway, so this folder here, in this folder, when we Terraform plan and apply and we apply the workflow, this VPC -vars, what it does is it creates this VPC for us, isn't it? Tomorrow, if we want to create the same VPC, but we want to change the name, we want to change the CIDR block, we want to add a different CIDR block, but we want to use the same provider, we probably would want to change the state. We want to use the same bucket, or want to use a different bucket, but we want to use a different key file, which is the file in the bucket. We want to use a different region. We want to call it not Bernard test CIDR. We want to call it whatever. Anybody can put any name there. How do we do this? Do we then create a new folder, which some people used to do? I've done that before when I started. What we did was we copy this folder and then we paste, and then we go into that folder and make changes to all of this, which is what you were all doing, which is you went in there and changed the values. Okay. But that's not a good way, good programming, the way of programming. Okay. This way is not the way to go. So you modularize it. Okay. Now, let's say this is a module. So if this is a module, then it's going to be an entity sitting somewhere on its own. Okay. We just have to make it that someone can reuse this module. Okay. So if I want to create another VPC, what I'll do is I'll create my own folder, and in there I'll call it VPC from module. I just, so that I know that I'm using this to create a VPC from a module. Okay. Right. This module is not ready. It's not ready. We need to do some things in it. So we're going to use this as a module. We're going to create another VPC. Okay. Now, the way you do it is you go in there, and every Terraform requires at least 3 files. Okay. Like we've done here, every one of them. So I'll create one file. I'll call it main. Normally people call it main.tf. Okay. I'll create another one, and I'll call it variables. Sharon.tf. I'll create another one, and I'll use that for my outputs. See how the thing is going. So from now onwards, we've also learned that we don't need these files. We can have one main file and just put everything in it. But for simplicity and for other people who are also going to work on this, it's easy for them to know that, oh, if I want to edit the outputs, I'll go to the output file. If I want to do something about variables, I'll go to the variables file. So these are the main 3 that we add. There are more. Okay. Now, in the main, we are not going to obviously create a VPC like we did here, where we created a VPC with a VPC resource. Okay. There's another block that we're going to start. It's called the module block. Okay. So let's go and find Terraform module block. okay, let's go back. This guy was, Google has now added an AI here that gives you an easy in what it is and blah blah blah, which is good. Here's more on Terraform module block. The Terraform module block is a feature in Terraform that allows you to define and manage multiple related infrastructure resources as a single unit. A Terraform module is a self-contained collection of Terraform configuration files that can be reused across multiple infrastructure deployment. There you go. So this is how the module block looks like. And as all the blocks that we started, it just starts with the name module. So we have a resource block, a variable block, and it starts with the name module. And then you give it a name. This is your own name that you're going to give it. Okay. So here the source argument is a mandatory for all modules. Okay. But and the version and all that. Okay. So here, as you can see, they gave it a name console and they're saying where the module sits. So let's copy this, go into our Terraform, go into our new main, and then we put this here. So here we'll call it Bernard test 2. Okay. So we're creating a module, and the module name that we are calling it, because you can create multiple modules. Yeah. We're calling this module Bernard test 2. And they said a module requires a source. That's the basics. So I will remove this. So as you can see, we started the module block, we named the module, and then we opened curly bracket, the same we've done, and we closed the curly bracket. And in there, we are going to add the parameters. And the first one is the source block. The source is where you're telling it where to, which code do I reference? Where is it? Where does it sit? And here, it doesn't matter. It can sit anywhere in the world. It can be a HTTP URL. It can be a Git repository. It can be anywhere the code sits. Fortunately for us, the code is sitting on this machine, local machine, and we can see it here. Okay. So if we go to here, you can find the location of this module, which is PWD, and it's there. Okay. This is where it sits. So, well, the people are sleeping. But one person is sleeping. It's not one person, not people.
No, actually.
Come on, go. Okay. You can put the absolute path. You can put whatever. You can anything. Okay. So let's try this absolute path and say, but it has to be in inverted commas. Voila. So we're saying that the source of this VPC that we are creating is here, right? Okay. Now, they can watch TV. Mommy knows. The source is here. Now, the module requires some items, some things. If we run this now, it will fail. Well, it might not fail, but it will just go and use everything that was used to create this resource. Okay, so let's try it. What we have to do is then change into that folder. Okay, and as any new, let's save it, of course, as any new as any new Terraform, you have to initialize. So what it's doing is downloading from here. Yeah, as you can see, it's taking the code from here and it's putting it in its own Terraform, and obviously there are errors. But let's read here. It says downloading file this, okay, and it's going to use it to create this module, okay, and then it's going to put it in its own modules folder in this here, okay, and then it would use that code. Based on that, it saw that it's using AWS provider, it's using, and then the version and everything, and all that. I know it's going to cause problems because we haven't done anything to the module to make it useful. So there's a conflict because the backend it's already there. Okay, so we are creating another VPC and we're saying that the backend in Terraform here, any selected backend applies to the entire configuration. The Terraform expect provider configuration only in the root module. There's a warning this is a warning rather than redundant empty block here. Well, it's just given us warnings, okay, but I know this will fail. It has initialized it, and in this folder ls-alt, you realize that it created its own terraform.tf terraform folder and the lock for it as well. It also has obviously the variables which is empty and the output which is empty. All we did was that. But can we plan and let's see what will happen? Well, we are expecting to create another resource, but just referencing it just like that, yeah. Is it going to, what's going to happen? You see, it's going to create 2 more resources, but it's going to call it, everything is going to be the same, just that it's also going to call it public 1, subnet 1. It's also going to it doesn't know about this resource. It's going to create it and it's going to add this. So if I apply this, it will create another resource. Let's see. Is it going to create another resource with the same name, the same everything? What's going to happen? There's a lot of warnings, but let's ignore it for now. It's actually creating it, and it's created that, and it didn't give us any outputs because in this file here we didn't say it should give us any output, so there's no output. But it said it's created it. Let's go to AWS and find this VPC. Refresh, and voila! You see, it's created another VPC with the same name, the same CIDR block, but a different VPC ID. It created another internet gateway. No, my code doesn't have internet gateway, so there's no internet gateway there. Okay, it created subnets, created 1 more subnet, and so on and so forth. So we can do this how many times? We can create this same VPC anytime we want. All we need to do is we need to create this block. That's it. That's it. Any questions?
So Ben, does this create a second state file, or it uses
No, it's using the same state file because we haven't specified a second state file. This one, what we've done is we haven't made any changes whatsoever to the code that we've already deployed. But it doesn't make sense. We will need to make changes to the code so that everything can be parameterized. We don't want to call it the VPC the same name. We don't want an exact same one. We want maybe to be able to say that for this new VPC, the CIDR should be this. For this new VPC, tag it this way. For this new VPC, put it in this state file. For this new VPC, do this. But that's where we're going to get to. How do we make sure that that module can be dynamic, can be properly reused? But I just wanted you to know that a module is this for now, and then we're going to build on it. You get my point? So for now, it's using the same state file. It's using the same state file. So if you look at the state file, you realize that it has information about both VPCs. Okay, it will have information about both VPCs. Let's test it and see. So this guy is not going to see again, so let me increase it. It doesn't work. So Terraform state list. What will happen? Because we are using the same state file. What will happen? Let's see. If we have all the information about all the VPCs that has already been created. No, so this one is got its own different, because it's a module. The state file, if I download the state file and we look at the state file, we will see information about both of them. But because this has a module in front of it, Terraform knows that even if it goes to the state file, it will only bring you information about this. If you go to the other one, yeah, cd dash, and then we do Terraform state list, the main one, you see that one also, it doesn't have module in front of it. So even though it's using the same state file, based on the fact that one of them is a module, the other one is not. So Terraform is that smart. You can use that one state file to manage all of your state. You get my point? But if we download the state file and open it, let's try it. You'd see that it has reference to all the others. So S3, the state is sitting in S3. And then this is it. This is the file. Let's download. And it's a JSON file. Let's open it. So we have this one. It has an output. These are the outputs. Yeah. And it has resources. And this is the resource here. First resource. And when you go down, it's got this. And the VPC. It's got a subnet. And is that what's going on here? It's like there's only one. I don't understand this. Oh, let me see. This was a very good question, actually. Let me see. CD dash again. LS minus ALT. Oh, Paul. Basically, it's good that you asked. basically in this module, we are not using the state file at all. So what it means is, if you start a module, you need to you also have to add information about the state, where to put it. So I think these are the warnings we are seeing here. It's not going to use that same state. It's going to create its own state. So it did the state file, but it put it here.
Yeah.
For this module. Yeah, so it didn't use that same one. So and I think that's what the errors are. So we need to add the block for the backend if we start a new module. Okay.
Yeah.
We need to add the block for the backend. So my bad there. Okay, so that means that there are two requirements. The first one will be the backend and the module. Okay. So if I copy this and take it here, I can actually put it here and I'll say -2. I'm using the same bucket, I'm using the same region, but I'm creating a new file and that. So let's Terraform plan again. Let's just apply. Apply we need to initialize. And then it's going to copy the state file and put it in. You want to copy existing state to your new backend? Yes. So it basically is moving the state file to the remote backend. Okay. Let me see. Just that block that we added meant that it's now putting it in the backend for us. Could we have used the same file? That's something that we can also learn and practice and try out. Can we use the same state file? What would happen if we use the same state file? So we are using a module block and we are passing where the module sits, but of course we have to also tell where this state file will sit as well. Okay, so if we go to AWS now and we refresh this bucket, there will be two files there. There should be two files there. Let's see. Yeah, okay. So this one is for that, and that one is for the first one that we created. Okay. Which means that each infrastructure, because the module is on its own infrastructure, but we're using a code that we've already developed, and which means that all you have to do in Terraform is to make work on modules, and then the rest, people will just use the module. Everybody everywhere can use the modules. Yeah. So we will leave it here because we don't want to get too much into it for one day. We'll continue on the moduling, but we'll make sure that when we create the infrastructure, the module will be unique. It will not be, we can create a VPC and say, okay, we're using the VPC module, but we want the CIDR block to be this, we want this to be that, we want this to be that. How do we do that? And change everything so that everything that whenever we create it, it will be something that is required to change. Okay? Any questions?
No questions.
Happy days. Next weekend, we meet again and we'll continue with terraforming. If I get time this week, I'll prepare some questions. And then when we meet next week, we will work on them. Okay. Everybody will have a go at these questions, how you answer them. And then we will see. but we are aiming to sit the exam. Okay. Thank you very much. See you later. Bye.
Thank you,
thanks,
Benny.
Bernard.
See you.
Bye.
Bye.
Right.